So this video is going to be about solving systems of equations using elimination. So just like everything else that we've been doing, we have three different possible solutions. One solution, everything solves just fine. No solution would be that same thing. At the end, you get something like 2 equals 7, so different numbers. And then infinitely many solutions is a little bit different from substitution, because instead of you just getting 0 equals 0, everything cancels out when you try to eliminate. So we're going to look at two different examples. One where both equations are in standard form, and one where both equations are not in standard form. So standard form is this. So you have to have your x's first, your y's first, and then it equals some number on the other side. So both of these equations are in standard form. So yes, they are in standard form, so we do not need to take this detour. Are there equal and opposite variables? So I'm looking for things like 3x and negative 3x. So if I'm looking at these two equations, I'm looking at this number and this number. I'm looking at this here. So 6 and negative 4 are obviously not equal and opposite. 2 and 2 are equal, but they're not opposite. I need one to be positive and one to be negative. So this is going to be a no. I have positive 2y and positive 2y. So I need to detour and multiply one of the equations or both of the equations by a number so that I get equal and opposite variables. So I'm just going to go with that first equation there, 6x plus 2y equals negative 6. In order to change this plus 2 to a negative, I'm just going to multiply the whole equation by negative 1. So 6x times negative 1 is going to give me negative 6x. Negative 1 times positive 2y is going to give me negative 2y. And times negative 6 is going to give me positive 6. Now I'm going to take this equation, so my negative 6x minus 2y equals 6, and my other equation, so my negative 4x plus 2y equals negative 6. Negative 4x plus 2y equals negative 6. And I'm going to add these equations together. Negative 6x plus negative 4y is going to give me negative 10x. Now here's the whole point of elimination. The negative 2y and the positive 2y cancel out. They eliminate. If in this step where you're adding, things do not eliminate, then it means that you haven't done something correctly. And then 6 plus negative 6 is going to give me 0. This step here, I'm going to solve this equation for x. So I'm just going to pull this down, because technically it's on a different page. So negative 10x equals 0. I am just going to divide both sides by negative 10. And I'm going to get x equals 0. Now I'm going to take that up to one of my original equations, so original ones, not ones that I've multiplied, and substitute it in and solve for the remaining variable. So again, I'm just going to go back up to that first equation, 6x plus 2y equals negative 6. So I'm plugging in 0 for x, and then I need to solve for y. So 6 times 0 is 0. Now, technically I don't need to do this step, but I want you to see all of the steps. Divide both sides by 2. And I get y equals negative 3. So right now, I think my solution is y equals 0, negative 3. So I'm going to check this solution in my other equation. So now I'm going back to the negative 4x plus 2y equals negative 6. So I'm going to plug in 0 for x, negative 3 for y. Not sure if this is equal to 6 yet. That's what we're checking. So negative 4 times 0 is 0. 2 times negative 3 is negative 6. So 0 minus 6 gives me negative 6. Negative 6 is in fact equal to negative 6. My solution here is 0, negative 3. So that's the process for elimination when you have it in standard form. Let's look at when we do not have equations both in standard form. So again, I'm looking for ax plus by equals c. This equation is in standard form. This one is not. So this is no x equals y plus 1, not in standard. So I need to solve this equation so that it is in standard form, or rewrite the equation so it's in standard form. I need to move this y to the other side. So I am going to subtract y from both sides, and I get x minus y equals 1. Now it's in standard form. My x's and my y's are on the same side. My constant is on the other side. So next step, are there equal and opposite variables? So I'm going to rewrite the equations that we're dealing with here. X minus y equals 1 and negative 2x plus 3y equals 2. So no, again, I do not have equal and opposite variables. There's nothing in front of my x, which would make it a 1. And then my y's are a negative y and a positive 3y. Neither of those is equal or opposite. So I need to multiply one of my equations, or both of my equations, by a number so that I get an equal and opposite variable. The easiest one is going to be this negative 2 here. I can multiply my first equation by 2 to get that x as a 2, which would be equal and opposite to negative 2. So I'm going to multiply. My plan is multiply x minus y equals 1 by negative 2, or sorry, not negative 2, by 2. So I'm going to take x minus y equals 1. I'm multiplying everything by 2. So 2 times x is 2x. 2 times negative y is negative 2y. And 2 times 1 is 2. Now I'm going to take that equation and back to my negative 2x plus 3y equation, and I'm going to add them together. So the negative 2x, the 2x and the negative 2x are going to cancel out. Again, that is the whole point of elimination. If nothing cancels out at this step, then you know you've done something wrong. Negative 2y plus 3y is 1y, and 2 plus 2 is 4. I'm going to divide both sides by 1. Technically not necessary, but again, I want to see you to see every step. So right now I've got y equals 4. Wrong spot, we'll say. Should have gone in both of those. Okay, so now I'm going to take that back up to one of my original equations, and the easiest one's probably going to be that x equals y plus 1, and again, it's one of the original equations. So x equals, I think y is 4 plus 1. This one's nice and easy to solve. 4 plus 1 is just 5. So right now, I think my solution is 5, 4. I'm going to take that back up to my other original equation, which was negative 2x plus 3y equals 2. And I'm going to plug it in, 5 in for x, 4 in for y. Not sure that those are equal yet. So negative 2 times 5 is negative 10. 3 times 4 is 12. Not sure if that's equal to 2 yet. Negative 10 plus 12 is in fact 2. 2 equals 2. I did this correctly. So my solution is 5, 4. So that is how you are going to solve systems of equations by eliminating.